Okay, so in this lesson, we're going to factor using difference of squares, okay? So this is kind of a special one where we can only use it when we have a difference of squares. This little factoring chart will help you determine which method of factoring you can use, okay? So you would usually use greatest common factor if you have two or more terms, okay? But when you have a difference of squares, you only have two terms. So let's go to squares, okay? So we have 1, which is 1, sorry, this came out weird, which is 1 squared, 4, which is 2 squared, 9, which is 3 squared, 16 is 4 squared, 25 is 5 squared, and 36 is 6 squared, okay? So these are all perfect squares. So you should be able to list like 15 of them, okay? So you should know like 7 through 15 squared, and it will really help you be able to do these a lot quicker. Okay, so here is the rule for if you have an equation that looks like a squared minus b squared. So a number squared minus another number squared, we can rewrite it as a minus b, a plus b. Okay? You can also flip the order because it doesn't matter, we're just multiplying. It's like saying, oh, I have 7 times 2 or 2 times 7. Okay, the order does not matter. Okay, so if we use these steps, it will help you for any of them. So I'm just going to quickly go over them and then we're going to use them in the next example, okay? So if you want to factor a difference of squares, you have to say yes to all of these questions. Like, are there only two terms? Is the first term a perfect square? Is the last term a perfect square? Is there a subtraction in the problem, okay? So you need to say yes to all of these. So let's here try the first one. If you have x squared minus 25, okay, this is our problem we want to factor. So we want to determine if this is a difference of squares. So first, can we factor out a greatest common factor from here? No, but that's okay. All right, so now we need to make sure these are all true. Are there two terms? Yes, we have x squared and minus 25. Is the first term perfect? Yes, because it's 1, right? 1 squared is 1. Is the second term perfect? 25. Yes, 5 times 5. Sorry, I'm going to write it in here, 5 squared. Are we using a subtraction problem? Yes, we are, okay? So that means that we have a minus b and a plus b, okay? The first term is like our a, and the second term is like our b, okay? So a is 1 and b is 1x and b is 5. So I now just have x minus 5, x plus 5, okay? So let's try this next one. So when we are factoring, we first want to look at, can we take out the greatest common factor? So here I have 75x squared minus 12. Okay, so let's take out the greatest common factor, which is 3. So when I take out 3, I have left over 25x squared minus 4. Now we can check to see if the difference of square steps are true. Do we have two terms? Yes, we have 25x squared and minus 4. Is the first term a perfect square? Yeah, it's 25x squared, so it's really 5x. Okay? The second term is minus 4. Okay? So that really is 2. Okay? And both of these are squared. Are we using subtraction? Yes, this is a subtraction problem. So I can rewrite it as 5x minus 2 and 5x plus 2. Okay? I can't forget about the number that I took out, which is 3. So now I have 3 times 5x minus 2, 5x plus 2. Okay, so let's do one more of these together. So 16x squared minus 9. Is there a greatest common factor that I can take out? No, there is not. Okay? So are there two terms? Yes. Is the first term perfect? Yes. It's 16x squared. So if I took the square root of these, I would have 4x. Is the second term perfect? Yes, it's 9. So that really is 3 squared. So if I take the square root, I have 3. Is this a subtraction problem? Yeah. Okay, so it will work. So this is basically here my A and my B. So A minus B and A plus B. Okay, I didn't take out a greatest common factor, so this is my final answer. Okay, so let's do one more here. Okay, so is there a greatest common factor? No, not between the two of these. Are there two terms? Yes, I have 81a squared and 49b squared. Is the first term perfect? Yes, it's 81a squared. Okay, so if I unsquare it, I take the square root, I get 9a, which is a. The second term is 49b squared. Sorry about that. The second term is 49b squared. Okay, this is perfect also. If I take the square root, I get 7b. This is going to be my b. And I do have subtraction right here. So I did answer yes to all of these. So my A is 9a, and my B, 7b. So A minus B, A plus B. Okay? So remember that you can always double check these to make sure that you're right. Okay, so let's just go ahead and do this one. 9a times 9a, 81a squared. 9a times 7b, 63ab, minus 63ab, and minus 49b squared. Okay, so notice that the center terms cancel out because one's plus and one's minus, and we're left with 81a squared minus 49b squared. Okay, so always double check your answer. Just FOIL it to see if it actually comes out to be what you started with. Okay, so here in part 2, we're going to try and apply like a lot of the different factor terms that we learned about. And then we're also going to solve equations by factoring. Okay, so here in the first one, I'm just going to go ahead and rewrite it to make it look a little bit better. Okay, so I see that I have 4 terms. So anytime you have 4 terms, you know that you can use grouping. So let's go ahead and group these. Okay, now I'm going to factor out what I can from each one. So in the first one, I can factor out a 5 and x squared. Okay, so what would be left here is x plus 3. Okay, in the second one, I can factor out a negative 5. Okay, and what I have left is x plus 3. Okay, so you want it to be so that these are the same. Okay, so my outside becomes the first one, 5x squared minus 5. And the second one is x plus 3. Okay, but now here I actually have to go ahead and factor one more time. Okay, because I see that here I can factor out again. I can take out a 5 and I'll have x squared minus 1. And then here I'm going to have x plus 3. Okay, except I can't leave this x squared minus 1. Okay, I know that this here is a difference of squares. So what I can do is a is x and b is 1. So x minus 1, x plus 1, in for here, then bring down the x plus 3 and also the 5. Okay, so now this one has been factored completely. Okay, let's try one more here. So here I have 2x to the 4th minus 162. So let's do greatest common factor. Okay, so we want to think about what we can use. It's not a trinomial, there's not 4 terms. Okay, so I'm going to use greatest common factor and I'm going to take out the 2. So now I have x to the 4th minus 81. Okay, I'm going to break this down even more because this really is x squared squared. Okay, and 81 is really 9 squared. Okay, so now in the next step what I can do is write 2, and then underneath here I have my x squared minus 9. And then I also have x squared plus 9. Okay, because it was x to the 4th. So now that's why I have the squared squared minus 9 plus 9. Okay, so I know that I just learned in difference of squares that I can change this to x minus 3 x plus 3. Okay, bring down the 2, and then because this already started off as plus, it's as far as we can go. Okay, so just to remember what we just learned is difference of squares, okay? And here is going to be your final answer. Okay, so what I'd like you to do is pause the video and try this one on your own, okay? So this right here is x to the 3rd and x squared. Okay, so what you should have done for this one first is group because there are 4 terms. So I grouped the first 2 and the second 2. Okay, factor out what you can. Here I see I can take out x squared from both, and that's actually it. So x plus 3. In the second one I can factor out negative 4. And I'll have left x plus 3. Okay, so looking good so far. The outside becomes my first one, x squared minus 4. And then the one that repeats is x plus 3. Okay, so we actually have one more step here because this is still x squared minus 4. It's a difference of squares. So I can rewrite it as x plus 2, x minus 2, and then bring down the x plus 3. Okay, so now we have everything completely factored. Okay, so on this one in your notes, actually you need to add this so it's 18. Okay, so it should read 18x to the 3rd equals 50x. Okay, so we see equations. Anytime you see an equation, you always want to set it equal to 0. So subtract 50x, and I get 18x to the 3rd minus 50x is equal to 0. Okay, so now we want to think about the options that we have. We can do greatest common factor, we can do trinomial or grouping. Okay, but we know that in trinomials those are 3 terms, in grouping we need 4. So this one must be greatest common factor. So I can factor out a 2 in both of them and also x. Okay, so in the first term I have left 9x squared minus 25. Okay, so here again I have difference of squares. Okay, 9 is 3 times 3, and x squared is x times x. Okay, remember that one is minus and one is plus, And 25 is 5 times 5. Then bring down the 2x, okay, which is equal to 0. So because I'm talking about an equation that I need to solve for x, each one of these needs to be equal to x, okay? Or, I'm sorry, to 0. 2x equals 0, so here x is 0. 3x minus 5 is equal to 0. So solve for x here. So x is 5/3. And then solve for x in the last one. Okay, so I'm setting each part equal to 0. So x is equal to negative 5/3. Okay, so x has 3 answers here. X is 0, x is 5/3, and x is negative 5/3. Okay, so this last one I'd like you guys to try and solve. So let's pause the video here. Okay, so we want to set it equal to 0. So I'm going to subtract 64 to make it 0. So 9x squared minus 64 is equal to 0. Okay, so here I can see that I have a difference of squares. Okay, these are squared. So the square root of 9 is 3 times 3. X squared is x times x. So the first term, 3x. I know that one is minus and one is plus from the difference of squares rule. And then 64 is 8 times 8. Okay, and these are going to be equal to 0. So grouping them separately to solve for 0, 3x minus 8 equals 0. So here I have x is equal to 8/3. And in the second one, 3x plus 8 equals 0. So 3x equals negative 8. X is equal to negative 8/3. Okay, so 2 answers here. X is equal to 8/3 or negative 8/3.